Welcome to This Is My Architecture. I'm Matt from AWS, and today I'm joined by Russell Christopher from Tableau. Thanks for joining.
I'm psyched to be here.
So tell us a little bit about Tableau.
Well, Tableau is a tool to help people see and understand their data.
Great. I remember using Tableau back in my old job, like many years ago.
Yeah.
And it was, it really changed the game for data visualization at the time. It was great. And so obviously it's evolved a lot since then, and that's what we're going to talk about today.
Yeah,
right?
quite a bit. You can run that same tool that you love on the Mac now. We built Tableau Server.
Yeah.
That server can be deployed on-premise or on EC2 or other ways.
So users of Tableau have a few options. They can still deploy it on a server like they used to. They can also deploy server, I know, on EC2. But today we're going to talk about something else. This is kind of the next evolution, Tableau Online. Is that right?
Exactly. This is our cloud application to help people see and understand data in the cloud if they don't want to manage all of the bits and parts themselves.
So Tableau actually manages this service for them? Or?
Exactly. That's exactly what we do.
Great. So this is a multi-tenant, sort of per customer application. Is that correct?
Yes. We have multiple customers in each one of our clusters, and we hard partition them.
Great. OK. So you took what was an old desktop application and evolved it to a server and moved it to an online. Let's talk about how you evolved the architecture to be able to do that.
Sure.
So, first of all, I see you have a multi-tier. So how does traffic actually come in here? How do users sort of start with your application?
Well, we're looking right now, actually, at private subnets. Okay. We have way up here, you can barely see it. We do have a public subnet. And we have a NAT, which allows traffic to come in. And it is going to hit one of our two HA proxy instances.
So you're using HA proxy. Why not ALB or something like that?
Well, it's interesting. Because we are partitioning all of the work, we actually couldn't use rules in ELB to do that. Now, we probably could plug in ALB at this point to take advantage of that capability, but we went with what we know. So we stuck with HA proxy. OK,
great. So you have a combination of HA proxy and ELB to route traffic where it needs to go within the private subnet. OK, so you took this desktop application that was then a server, Tableau server on EC2 or wherever you want to deploy it, and then you have Tableau Online where you broke it into multiple services. Is that what these clusters represent?
Yeah, exactly. These are pools of machines that take on different roles.
Okay.
The first role is what we call a worker, and these machines actually render the visualizations for our users. So we might have one to many of these depending on what we need to do. And then we have a second role, which is our backgrounder role. It actually ingests data on a scheduled basis, almost like batch scheduling, and these are backgrounders. And we have 1 to n of these, and we can add more or take away as necessary to hit our SLAs.
So that's actually a big reason why a lot of people move to these multi-tenant SaaS applications, is they can have uptime all the time.
Yeah.
So you have multiple different types of load balancing up here. Can you do in-place upgrades without service disruptions? Or?
That was key for us. Using HA proxy, we can route or not route traffic to each of the individual machines in these pools. So when it's time to actually upgrade, we take machines out of our pool, we upgrade them, and we return them to the pool.
Great, so you can take a node out, do the upgrade, put it back in, and HA proxy will start routing traffic to it again.
Exactly.
Okay. So one thing that's interesting about this architecture, you have this multi-AZ, but you have multiple data stores. So let's walk through a little bit how you're using the different types of data stores. So starting up here, you have both Postgres and Elasticache Redis. So what are you using those for?
Well, Postgres is how we store a lot of our state. Usernames, et cetera, et cetera. This is how we achieve multi-tenancy. It's how we record everything that's going on.
So user sessions, whatever's related to the particular session of that user.
Exactly, exactly. Redis, in this case Elasticache, is one of our many layers of caching. So if I hit a cloud data source like Redshift, for example, and get an answer back, well, I'd rather actually store that and reuse it if I can. So.
Yeah, because performance is one of the big reasons why a lot of users, myself included, started using Tableau in the first place.
That's right.
This speeds it up.
Yeah. Yep.
Okay, so you have a caching layer for cached results from Redshift or other data sources. You have Postgres for sort of session data related to the SaaS application. But we also have these data stores. So where's the actual Tableau data stored? If I load data into Tableau, where does it reside?
The Tableau data extracts actually live in DRDB. So these are big replicated EC2 instances that act essentially as a big file system.
So you have EC2-based file systems. Are these Windows servers, Linux servers? What are you using today?
Yeah, that's the really interesting thing. This is all done on Windows because most of our customers are Windows shops, but that's actually changing.
Yeah, well, actually, Microsoft Windows is a great system to run on EC2, and a lot of our enterprise customers use it. So not surprising, honestly, especially for enterprise users that you guys are targeting.
Yep.
So you have these Windows file system-based DRBD for the actual assets related to Tableau.
Yep.
But you also have S3. What does S3 use for?
This is just static content, the images in our portal, et cetera. We just land them here and serve them through a CDN, CloudFront in this case.
Okay, so a bit like Postgres for the session data, this is the static assets for the web front end, the user experience.
You got it.
Great. Now, the last piece here, and I know this is talking about the future, you have EFS. So tell us about what you're thinking for EFS in the future.
Well, you kept eyeing that. I was kind of smiling. We're moving actually to Linux. We're porting the Windows Server product to Linux as well. And EFS is so good on Linux, we will retire DRDB and store all of those Tableau data extracts and artifacts in EFS instead.
Great, so it's one less thing to manage. You don't have to manage that cluster and the uptime, et cetera. You can just move it to EFS.
Right, we'd much rather deal with services than things that we have to manage ourselves.
That's great. Well, I like how you continue to evolve as a platform and really how you modernize this application over time and kept up with the pace of the times and with your users. It's really nice to see. And one last question before we go. You have a multi-AZ architecture. What if I want to run this in other regions? I know as a Tableau user, it's important that I'm near my data. So what if I'm in another region?
Yeah, absolutely. So what I'm showing you is called a pod. And we have pods all over. As you said, we want to keep the compute close to the user's data. So we have pods in East, we have pods in West. We're also in EMEA.
That's great. So we have a multi-AZ architecture, pod-based that can be deployed across regions. You're taking advantage of some of the newer services like EFS, and you've really taken this application that's been around for a while and evolved it into a multi-tenant SaaS application. It's nice to see.
Yeah, we think it's pretty cool.
So thanks for sharing your architecture with us today.
It was fun.
And thanks for watching. This is My Architecture.